Palmdale, California, September 18, 2000. A strange, wide-mouthed jet taxis toward the runway, unlike anything the US Air Force has ever flown. Inside the cockpit, test pilot Fred Knox runs through his final checks. Millions of dollars, years of engineering, and the future of American air power ride on this single flight. This is the Boeing X-32, a jet designed to win the largest fighter contract in military history. It should have become the most produced warplane on Earth. Instead, it lost, and today, almost no one remembers its name. What if one design decision, one compromise, had gone the other way? The entire shape of modern air power could look completely different. This is the story of the jet that dared to look different, and the program that decided America's fighter fleet for the next 50 years. By the early 1990s, the Pentagon faced a problem. 3 branches of the military were each developing their own next-generation fighter, separately, expensively, and inefficiently. The Air Force needed a stealthy replacement for its aging F-16s. The Navy wanted a carrier-capable strike fighter. The Marine Corps needed something that could take off and land like a helicopter. In 1993, the Pentagon merged these separate efforts into one ambitious program, the Joint Strike Fighter. 1 airframe, 3 services, 1 winner. The prize was staggering. A contract potentially worth over $200 billion and orders for thousands of aircraft across decades. Only 2 companies dared to compete for it all, Lockheed Martin and Boeing. Boeing's proposal was unlike anything the company had built before. It called for one radical solution to solve 3 completely different missions. Boeing's design team, led out of its Phantom Works division, began sketching a jet built around a single enormous air intake beneath the cockpit. That intake would feed a single massive engine, the same core Lockheed was using, but wrapped inside a completely different airframe philosophy. In 1996, both companies were awarded contracts to build competing prototypes. Boeing called theirs the X-32, Lockheed Martin called theirs the X-35. For the next 4 years, in secured hangars in Palmdale and Seattle, Boeing's engineers raced to build a jet that could outfly them all. The X-32's most striking feature was impossible to miss, a single, gaping chin intake that gave the jet its nickname, the Flying Shark. Behind that unusual face was real engineering logic. A single large duct fed the engine efficiently across every flight mode, from a runway sprint to a vertical hover. Boeing built the X-32 around a delta wing, a single, enormous one-piece composite structure borrowed from decades of experience on commercial airliners. That single-piece wing saved weight and cost. But it also meant the jet could not fold its wings, a serious problem for cramped aircraft carriers. To achieve short takeoffs and vertical landings for the Marine Corps, Boeing chose a direct lift system, redirecting the engine's exhaust straight down through swiveling nozzles. It was simpler than Lockheed's approach, which used a separate shaft-driven lift fan. Simpler, but it demanded far more raw thrust and far more heat management. The cockpit sat high and forward, giving pilots an almost panoramic view, a deliberate choice to maximize visibility in a dogfight. Beneath the skin, Boeing built the X-32 with an eye toward affordability, aiming to reuse as many parts as possible across all 3 military variants. On September 18, 2000, the X-32 took to the sky for the very first time over Palmdale, California. Test pilot Fred Knox guided the strange-looking jet through its first turns, watched by engineers who had spent years waiting for this single moment. Over the following months, the X-32 flew dozens of test flights from Edwards Air Force Base, proving out its conventional takeoff and carrier approach handling. Then, on March 29, 2001, its sister aircraft, the X-32B, took flight for the first time, built specifically to prove short takeoff and vertical landing. Engineers watched anxiously as the X-32B slowed to a hover, its engine screaming as it fought gravity on redirected thrust alone. It worked. The X-32B successfully demonstrated vertical landings, proving Boeing's simpler, direct lift concept could function in the real world. But hovering wasn't the hardest part. The true test was the transition, shifting from a hover back into forward, wing-borne flight without losing control. That maneuver demanded enormous engine power and precise control, and it exposed just how much weight the X-32B was carrying. Behind the scenes, Boeing's engineers already knew the aircraft needed a redesign. The delta wing was proving too heavy, and its performance margins were too thin. Boeing proposed a new configuration, smaller, more conventional swept wings and a redesigned tail. But this version would never actually fly during the competition. Meanwhile, across the country, Lockheed Martin's X-35 was flying its own trials, quietly proving a lighter airframe and a more sophisticated lift fan system. In July of 2001, the X-35B achieved something extraordinary: a short takeoff, a supersonic dash, and a vertical landing, all in one single flight. Boeing's X-32 could not match that single feat. Its heavier airframe and simpler lift system left it with a narrower performance envelope. Throughout the summer of 2001, both companies submitted final data packages to the Pentagon, thousands of pages of flight results, cost projections, and engineering promises. On October 26, 2001, the decision came down. The Pentagon selected Lockheed Martin's X-35 to become the Joint Strike Fighter. The X-35 would go on to become the F-35 Lightning EL, the most expensive weapons program in history, with thousands of aircraft eventually built for over a dozen countries. The X-32, meanwhile, quietly flew its final test flights and was retired without ever entering production. Both prototypes were preserved rather than scrapped. The X-32A now sits at the Air Force Flight Test Center Museum at Edwards Air Force Base. The X-32B found its permanent home at the National Museum of the United States Air Force in Dayton, Ohio, a monument to the jet that almost was. It's easy to call the X-32 a failure, but that misses the point entirely. This program never intended to produce just one winner in isolation. The competition between Boeing and Lockheed Martin forced both companies to solve nearly impossible engineering problems: stealth, speed, and vertical flight, all in one airframe. Many of the lessons learned from the X-32's direct lift experiments and its lighter manufacturing techniques quietly influenced how the entire Joint Strike Fighter program matured. The loss was also a turning point for Boeing itself, reshaping how the company would compete and cooperate in military aviation for the next 2 decades. And for engineers, the X-32 remains a case study. Proof that even a losing design can push an entire industry forward. More than 2 decades later, the F-35 dominates Western air power, flying for the United States and more than a dozen allied nations. Its lift fan STOVL system, the very technology Boeing's simpler approach once competed against, remains one of the most complex mechanical systems ever installed in a fighter. Had Boeing's direct lift concept won instead, today's fighter fleets might look and fly very differently, built around simplicity rather than mechanical complexity. The chin intake design Boeing pioneered on the X-32 also foreshadowed intake concepts still studied today for next-generation combat aircraft. Well, eastudi in any HR. Meanwhile, the X-32 itself remains frozen in time, a monument in 2 museums, visited by thousands who rarely know the scale of what it once competed for. History remembers winners. But the Joint Strike Fighter competition proved that even the aircraft that loses can still shape the future of flight. Boeing's engineers gambled on simplicity and affordability. Lockheed Martin gambled on complexity and refinement. In the end, only one bet paid off. But both aircraft pushed the boundaries of what a single fighter jet could be asked to do, and both left their mark on aviation history. Today, the X-32 sits quietly under museum lights, no longer flying, but never forgotten by the engineers who dared to build something different. It was the aircraft that almost changed everything. A reminder that in aviation, as in history, the margin between legend and footnote can be razor thin.